MOTSOENENG from the Tshwane University of Technology in South Africa. I am honored to present my research at the International Scientific and Practical Conference 2025. It is a privilege to share my insights from my study on robotics process automation, readiness in South Africa's energy industry supply chain. This study was motivated by the fact that South Africa's energy industry faces numerous structural pressures such as power outages, aging infrastructure, supply chain inefficiencies, amongst others. The persistent challenges demand innovative solutions available through digital transformation to maintain and sustain supply chain reliability in this critical industry that supports social stability and economic performance. RPA offers potential to reduce manual effort, increase process efficiency. However, limited evidence exists on how organizations prepare for automation adoption of this nature in this context, hence the research gap. Therefore, this study aimed to examine how technological, organizational, and environmental factors interact to shape readiness for RPA and to identify the enabling practices that can strengthen RPA in this context. Key insights from existing literature on RPA readiness indicate that technologically, automation improves reliability, but it often is limited by weak integration and low investment. Organizationally, readiness depends on leadership commitment, governance, and workforce engagement, while regulatory clarity supports sustainable implementation. Overall, scholars agree that RPA readiness is multidimensional, requiring both structural as well as behavioral alignment. In South Africa's energy industry, there are persistent inefficiencies, leadership turnover, resistance to change, and regulatory gaps that continue to constrain readiness, making the study that much more relevant. To address the identified gap, this study adopted a dual lens framework combining two frameworks. The Technology Organization Environment, or TOE framework, examines the structural dimensions of readiness, focusing on infrastructure capability, leadership alignment, and external regulatory pressures. This framework helps us assess an organizational, technological, and institutional capability to adopt RPA. The ATCA change management model complements this framework by addressing the human and behavioral aspects of readiness. This model moves through 5 stages of awareness, desire, knowledge, ability, and reinforcement, reflecting how individuals adapt to change. By integrating the TOE and the ATCA frameworks, the study connected technological capability with organizational behavioral readiness. This dual lens perspective offered a practical way to understand and strengthen RPA readiness, particularly in the context of emerging economies. The research was conducted within a large South African energy organization whose supply chain operations are directly impacted by the inefficiencies, regulatory pressures, as well as workforce concerns. Ethical clearance was adopted and all interviews was recorded with explicit participant consent. A qualitative design was adopted using semi-structured interviews to examine technological, organizational, as well as environmental and behavioral readiness for RPA. 18 participants were purposely selected across 8 stakeholder groups, including supply chain managers, IT specialists, and change management professionals. Data were analyzed thematically using Atlas CIEE, combining inductive and deductive coding, with rigor ensured through reflective note-taking and peer debriefing. Data saturation was reached after 15 interviews, and all participants provided the informed consent under the approved ethical clearance. Findings. through systematic coding and thematic analysis of participant narratives, an integrated framework that links identified barriers to corresponding enablers through the ADKA change management model emerged. 4 main barriers were identified through the TOE framework. That is infrastructure strain, job security and resistance, organizational misalignment, as well as readiness gaps. Each barrier was aligned with targeted enablers such as capability audits, leadership visibility, structured communication, and regulatory frameworks. Through ADKA, these enablers build awareness, desire, knowledge, ability, and reinforcement, ensuring that both structural as well as behavioral readiness are addressed for successful RPA implementation. The findings show that RPA readiness is systematic. It is shaped by interdependent technological, organizational, and environmental factors. Poor organizational coherence weakens technological reliability, while leadership instability and regulatory uncertainty intensified infrastructure strain. 4 major barriers emerged as discussed. These barriers interact dynamically, amplifying one another when left unresolved. The enablers identified, including leadership accountability, governance alignment, and regulatory frameworks, also have cascading effects through the barriers. When applied collectively, they stabilize infrastructure, strengthen communication, and create the conditions for sustainable RPA readiness in South Africa's energy supply chain. This study demonstrates 4 key strengths. Contextual depth. The focus of South Africa's energy industry offers rich context-specific insight into readiness challenges. Stakeholder diversity. Diverse perspectives from the 18 participants across 8 stakeholder groups provided a comprehensive view. Theoretical rigor. The integration of the TOE and ADKA frameworks enabled a structured analysis connecting technical and behavioral dimensions. Practical relevance. The findings offer actionable guidance for managers through enablers mapping to identified barriers. The study acknowledges 3 main limitations. A single organization focus restricts generalizability across South Africa's energy industries as well as other industries. The cross-sectional design provides a snapshot in time, limiting insights into how readiness evolves or how enablers perform over a long term. While qualitative approaches provide depth, it lacks quantitative validation of barrier frequencies and enabler effectiveness. This study makes 3 key contributions. First, it provides empirical evidence from an emerging economy through the first systematic analysis of RPA readiness barriers in South Africa's energy supply chain, addressing a major knowledge gap. Secondly, it introduces an integrated theoretical framework that combines TOE and ADKA, linking structural capability with human readiness. Thirdly, it delivers actionable enablers mapped to barriers, offering practical guidance for managers and policymakers to strengthen the governance, communication, leadership visibility, and regulatory alignment. Recommendations for practice. For managers seeking to improve RPA readiness, they should view automation as an organizational transformation rather than a technological upgrade. The evidence demonstrates that readiness improves when leadership is visible, communication is structured, and employees are involved early in the automation planning. From a policy perspective, the evidence suggests that organizations would benefit from clear automation and data governance guidelines supported by formal readiness standards. Participants observed that reactive engagement with regulators often delayed projects, necessitating a more proactive and collaborative approach between policymakers and organizations. Future research. Future research should focus on testing and refining the proposed framework across other energy organizations, as well as emerging economies to determine its transferability. Comparative and longitudinal studies could further explore how readiness evolves over time and identify enablers that are context-specific versus universally applicable. Quantitative validation and theoretical extension would create a comprehensive research agenda that addresses the multidimensional nature of automation readiness while maintaining practical relevance for managers as well as policymakers. In conclusion, the study explored robotics process automation readiness within South Africa's energy industry supply chain, addressing a critical gap in evidence from emerging economies. Through interviews and 18 professionals across 8 stakeholder groups, 4 key barriers were identified. The identified barriers were mapped to practical enablers. By integrating the TOE and the ADCA change management model, the study offered a dual-lens perspective that is novel and that connects structural capability with human readiness for change. The findings carry important implications for both practice and policy. For managers, the research demonstrates that RPA readiness must be institutionalized through visible leadership, clear accountability, and early employee involvement, and that psychological safety as well as structured communication enables readiness. Continuous and post-implementation reviews also build trust and reinforce the change. For policymakers, the results highlight the need for consistent automation guidelines, proactive regulatory consultation, as well as frameworks that align compliance with innovation to support sustainable automation in critical industries. For a detailed discussion of the findings, methodology, and theoretical contributions, the full published research paper can be accessed via the provided link. I thank you for the opportunity to share this research, and I appreciate the organizers of the Culture, Innovation, Education and Society 2025 conference for creating a platform that offers collaborative and knowledge exchange. I also want to extend my gratitude to my supervisors, participants, and the Tshwane University of Technology for their continued support. Thank you.